So I can continue. Hello? Yes. Yes. Okay. So I don't know where I was distracted, but anyway. So key challenges are like this. We have say low yield. There are unwanted delays. Coal quality are not predictable. So it is affecting say coal quality at then, and variability, different type of variables are too many who are affecting the process. So this whole thing can be achieved by digitalization, where we are seeing that most of things will be driven through analytics and some of the AI model, whereby we will optimize the process so that throughput can be increased by reducing the coking time, quality will be improved, and thereby cost also will decrease. I'm not going to this slide because time cost and other things, so I will be into this one main thing. So now, how the key challenges can be mitigated? Key challenges are we have to have say reactive decision, low yield or high ash content, moisture instability, delayed feedback about the process, coal quality variation, and due to say improper sequencing or improper operation, the machines are not available, so coking times generally increases. So when we talk of say reactive decisions possible only when we are making the complete process fully transparent. And once it is transparent, then proactive action can be taken by the system, proactive action can be taken by operator. Second thing is that when we talk of say yield optimization or improvement in the yield, then we have to identify that what are the dependency factor, whether the dependency factor is the machine or whether the dependency in the scheduling part itself. And if I can make the scheduling such a way that whatever gaps are coming up due to say non-availability or delayed operation of machine, that can be addressed and we can improve it. And so too for each and every item. I'm not going to each because well known. One important thing which I would like to touch upon, that is the coal quality variation and coking time. Although coke quality depends directly on blending, but nevertheless it also depends upon the cooking process. If I talk of percentage wise, the cooking process itself can improve the coke quality by 3 to 5% for the same type of blend. And cooking time variability also comes into picture due to delayed operation in particular oven. So how to mitigate it and how to address it, that is one of the key challenge. Now let us take say one simple example for say whole process. We are talking of say physical layer, coke oven battery, and typically we have say PLCs, SCADA system, and edge gateway where the data we are taking it to our system. Second layer is the digital twin. This is the main brain whole gamut of operation or gamut of say digitalization, where digital twin come into picture in two ways. One is say control point of view. Second is to identify if something happens. It means that you can go immediately simulation mode if you want to check something or check whether if I change certain variable, how it is going to get affected. That is one thing. Second thing is that digital twin will have say very good what I can say representation based on say analytics, so that any operator or any shift engineer can take immediate decision. And this analytics passes on to the AI ML model, and particularly here we are talking of say three models. One is say coke and temperature prediction, CMT prediction, 2 hours in advance. Second thing is that CSR prediction without having say lab information, so that we can take the corrective action in the next pushing and next cycle of pushing. And as I told you that it has a simulation engine which allows you two ways. One thing, it allows you to check if you will do certain variation, then how it is going to affect it without directly impacting to the process. And second thing is that if you want to train the operator, then simulation engine is very, very powerful to train the operator how the whole co-current battery to be operated and what type of decision to be taken under what condition. So this AI ML model does three major functions. One is the co-killed improvement, and co-killed improvement primarily we are saying that two part. One thing is that we are optimizing say co-current machineries who are responsible for say pushing and charging most optimum way, so that pushing can happen at a desired time. And in our model, we have given one concept called say buffer time. Buffer time plays a 10 to 15 minutes, keeping say overall target time. Let us say that overall pushing target is say 93 oven per day. 93 oven roughly comes around 18 hours of cooking time. But we will play such a way that it should not go for 17 hours, it will go not 18 hours. Let us say that it should go little lower, so that we have the buffer. And this buffer time utilizes in two ways. One thing is that in case say some oven pushing or charging is delayed, so it can be absorbed within say buffer time, or everything has gone very smoothly, then you are getting extra time whereby you can have say at least extra pushing. And this buffer time we keep it say 40 minutes. It means that whole planning is done not for 24 hours, it is being done for say 23 hours to 23 hours 20 minutes. That whatever pushing. So that buffer time constant is one thing. Second thing is that whenever we are saying say out of sequence pushing to be carried out and we want to bring it to sequence, it is operator's decision that how he is bringing that out of sequence oven into sequence. That how the out of sequence oven can bring to the sequence without we are talking of say yield improvement and say predictive information, so that either system or guidance system operator can take the decision. Deeper side. Probably on this topic I will come little later. I have kept 2 or 3 slides, that coal selection and blending fixing. On the conveyor, how we can propose for say blending improvement. Discuss in decide that what is going to be CSR target. Based on that one, the heating control model comes into picture, which does threefold operation. Wherever we have say mixing station, there we try to improve or try to maintain the CV value. And while saying so, in case if there is any chance that less availability of blast furnace gas, in that case we can have say CO mixing, thereby we can improve the CV value of say whole gas and we can reduce the volume. So this is the main thing, and other than that control and other things are there which I am not discussing because a very old thing. Each and every person or each and every supplier, including us, also will use a POS control. Second part is that we predict say heating uniformity across the oven. This heating uniformity tells us 2 or 3 more important information whether there is any localized heating. It means that we try to find it out whether there is a choking of a particular burner within the oven. Whether typically we say that coking side, coke side and pusher side we have say different arrangement for say gas and other things. Whether there is a decrease in the pressure and thereby flow from one end to other end. All these things based on say insight analysis we can identify, and this whole things goes management to avoid undercooking or overcooking. It means that we try to minimize or no green pushing or no hard pushing should not happen over there. Then we go for CMT. We predict that what is the CMT value required to achieve certain CSR value and whether we are getting it or not. If it is yes, then well and good. If it is no, we can extend the heating time and we can little bit delay the pushing sequence operation. And accordingly, the rest of the flow is going on. So, okay, I am not coming to this slide. How much time is allowed, by the way? As per planned, it was 10 minutes. So that's why I will skip something.
Yes, Mr. Chaudhary, you have been given 10 to 15 minutes time. So you can go on further for another 5 minutes maybe. After that.
Okay. Okay. So now in this one, and under the heading of say distillation, we are talking of 3 main parts, which I will not go in detail. One is that conventional heating control model we are converting to data-driven model. We are doing say code tracking and blending part. We are bringing that thing also under say Eagle Coke DT. Another module we are bringing, that is the coke oven management information system, that is machine CVM and oven CVM. Machine condition monitoring and oven condition monitoring. This is our say deployment process. How we go? We go for say dashboard, then we go the diagnostic, then predictive, then prospective, and finally autonomous operation. So these are the 4 pillars, and 5th pillar is fully autonomous. Fully autonomous means that there is no operator except SCP machine. Rest of the machines are SCP machine or say pusher car, whatever you say. and rest of the machine will be fully automatic without any operator. Again, I am not going to this slide. Slide already have sent, so you can go with this one. So each and everything is having certain business perspective. When we say that diagnostic, it means that we are reducing the losses. When we saying that predicting the CMT, CSR value, or say gas availability, depending upon say blast furnace operation or say coal yard coal availability, we can make it more stable. When we are going to the perspective, that is the optimization, we are improving the yield and we are decreasing the fuel rate. For each and every thing, we have say different models which are part of this legal code. Again, I am skipping. That is the concept how we implement it. I will touch the digital twin. The digital twin, how it works really. That is defined over here. And probably my presentation I will finish it in 5 minutes. But if possible, then I will take 3 minutes time actual visuals regarding say digital twin. So this is a digital twin operation where we are talking of say data splitter for these things. It is more towards say technology point of view that how whole thing are predicted. What really we are doing say real-time health index monitoring and performance monitoring. We are doing say anomaly detection, whether it is a process, whether it is a quality, whether it is a non-availability of machine. Every step we are finding say anomaly and we are generating the alerts with the suggestion. Not only alerts, we are suggesting also that what it's supposed to do. And we are also saying, when we talk of the machine, we are saying say remaining life. When talk of say oven, we say that when certain within a battery, when certain oven may create a major problem. And major point is that what if simulation? If something happens, then what is to be done? So that simulation model is also part of this one. I'm not going to this one, just it is giving business impact point of view. We are talking yield improvement by say 2 to 4%, fuel rate reduction, 3% guaranteed, 8% depends upon that way you are utilizing say fuel. If we have say connected power plant, then fuel rate can be best utilized. Unplanned downtime we are reducing. We will improve the battery life by having say even heating and proper heating, and overall productivity we are talking of say 5 to 10% increase. So these are the business impact. This is our goal, and this is the activities, major activities which we are going to do it. By this, the business impact is going to come like this manner. Blend optimization is one thing which I wanted to talk, or later stage also I can submit one requirement for this one separately. So we do say ML based programming for say blend optimization. Offline we have done this testing for say Rockefeller, we have taken say JSW, Bellary also data from that one, of course Tata Estate. So based on that one, we have checked that how our model is performing. So it is satisfactory. Moreover, I'm not going to this slide that how it is being done. Moreover, it is a real-time picture of the Rockefeller steel plant. We are going to propose that it is possible to little bit improve the blending while the coal is moving on the conveyor. We have say bunkers. All the bunkers are fitted with say profiling. So we understand that how much volume is charged. Depending upon say coal quality, we know that how much coal and what quality of coal we mixed. So accordingly, we can operate this screw feeder to allow the coal to go from the bunker to the conveyor. Main thing is that why it can be feasible or why it is going to be feasible, because we can have say online measurement of say this bunkers profiling. We have say profiling system, each bunker fitted, and we know that what is the volume or what is the height. We know the dimension, volume can be calculated. Many times there is a problem that although we set that how much coal to be discharged, but the problem is that whether rain is discharged or not, it is not able to be identified. But once we are putting say online measurement, this profiling system, then it is very much possible to identify whether the desired volume of say coal, particular quality of coal is discharged or not. This is during time of stacking also we can do it. What type of coal blend we need it. So this is a color combination indicating say different type of coal from different sources are put into this one. Once we hover onto this one, we get the detail. And based on say blending requirement, the escalation is reclaiming can be done, because our reclaiming system is fully automated, where we can adjust the slew angle and other things for reclaiming. This is the actual data that how we are presenting it for say manual adjust the coal blending, but automatically we are proposing the way just I mentioned. That's all. And let me check if I can just give me 1 minute time. If I can quickly connect, I don't know whether I can connect quickly or not. Just 1 minute. It is my fault that I'm just playing one digital pin which we have just developed as a prototype. I don't know volume you can. I think volume is very less. I think you are not able to hear. But I am saying that, see, it is the simulation mode where we can configure the number of batteries. You can decide the pushing, number of pushing, what you want, and simulate the fault, and see that whether operation is stopping or not. So the volume is there, so definitely it is not audible. Actually, I could have asked Sushanta to play this one. So anyway, there is no point in. Shall I continue or shall I stop it? Because you are not able to hear.
Audio is not.
Yeah, audio is not, because audio is in my this thing. But anyway, I'm just showing that how whole thing is advancing. You can stimulate, you rotate, you can get the detailed information, even the heating and other things. At what efficiency is working, what is the deviation, you can acknowledge or you can accept it. You can see that fuel train. And if you click onto the machine, you will get the detailed information. And I think that we missed it, few things. Anyway, so this is a one simulator which we are trying, but then it is only for presentation. But then this oven, when it will come, actually it is actually presentation of the oven of that plant. And there are multiple fields. We have say analytics, machine related information, battery related. So each and everything we can see. Any question? Hello.
Mr. Chaudhary, one thing for all the coke makers who are present here, everybody knows that mostly coke quality, almost 90 to 95% depends on the coal side. And
Yes.
maybe 5 to 10% max, it is depending on battery side. So probably we need to concentrate more on the coal side so that how to improve crushing, how to improve bulk density, how